Welcome to the Central Arkansas Astronomical Society's live stream event for Comet NEOWISE. And I'm Daryl Heath, the outreach coordinator for the Central Arkansas Astronomical Society. Bear with us tonight. We are using technology that we are not familiar with, and we're hoping everything goes without a hitch, but you know how these things are. If you're wondering why I'm kind of bathed in this eerie red glow, we are astronomers, of course, and so we like to see faint and fuzzy objects in the night sky, either with the naked eye or with our telescopes. And in order to see that fine detail in these objects, we need to let our eyes get acclimated to the darkness. And to preserve our night vision, we use red light, because the red light doesn't interfere, doesn't destroy our night vision as readily as does white light. So you may see us out and about at night with these red flashlights. This is a good observing tip, by the way. If you are a stargazer and you've got a telescope and you're wanting to see faint and fuzzy objects like a comet in the night sky, let your eyes get adapted to the dark. And in order to navigate around, just get a flashlight. Some of these flashlights nowadays have red LED lights in them. That's really good for preserving your night vision. You can also take just a regular white flashlight and put red film over it to create that red light and get rid of the white light. All right, so welcome to the Central Arkansas Astronomical Society's live stream event of Comet NEOWISE. As you've all seen in the news here lately, Comet NEOWISE is one of the brightest comets that we've seen in our sky in several decades, at least here in the Northern Hemisphere. I think the last one that I recall being as bright, or brighter actually, was Comet Hale-Bopp back in 1996, 1997. A spectacular comet that many of us here in the Northern Hemisphere were able to see. I can recall seeing it from my driveway in the middle of the city in Little Rock. This one, however, is not quite as bright. This one is kind of low in the sky. That makes it difficult to see. Whenever you see an object, a celestial object that's low in the sky, you're having to look through a thicker layer of the Earth's atmosphere. And it can distort and blur the image a bit. Also, because the brightness of this thing is so diffuse, it's not like a point source of light. It's not like a planet, or it's not a disk. It's not a point source like a star. It makes the object appear fainter when you have to look through that thicker layer of the Earth's atmosphere. But anyway, Comet NEOWISE was discovered back in March of this year, March 27th. And it was discovered by NASA's NEOWISE spacecraft, space telescope. NEOWISE is a telescope that's dedicated to looking for near-Earth objects. These are asteroids and comets that can come into the inner parts of the solar system and cross over Earth's orbit. And I don't want to get too scientifically technical with that, but in scientific terms, that can be like really bad. We don't want to have the Earth and a large asteroid or a large comet at the same place in the same time. So when we see these things coming in, we want to keep track of them. We want to know where they're at and what they're doing at all times. So NEOWISE helps us do that. And we want to make sure that they're not going to cross Earth's orbit at the same time that we're going through. So NEOWISE picked up this comet back in 2020, and we've been monitoring it ever since. And usually when we spot a comet like this coming into the inner parts of the solar system, when they go around the sun, they either vaporize and fall apart, and they never really amount to anything. Or if we're really lucky, sometimes they will brighten up and become like NEOWISE or Hale-Bopp. Now, like I said, we haven't seen a comet of this sort here in the Northern Hemisphere for at least the past couple of decades. The Southern Hemisphere, folks down there, have been luckier than we have. They've gotten to see some fairly bright comets over the years. So we're kind of overdue. And it's nice that we have this one in our skies right now. In order to see it, you need to get out right around 45 minutes or so after dark. Look towards the northwest, and right now the comet is below the Big Dipper. So if you know where the Big Dipper is and you have a good dark sky, you can locate the comet with binoculars. And I have to stress this a lot. Because the comet is so low in our sky, you're going to need a pair of binoculars or a small telescope to find it. Preferably use the binoculars, because binoculars give you a wider field of view and allows you to search a bigger portion of the sky than does a small telescope. I've encountered a lot of people over the past couple of weeks who've been out looking for it, and they're disappointed because they're expecting to see it at naked eye visibility. And you're hearing a lot of that in the media right now. This is a comet you can see naked eye. Well, you can if you have a really dark sky observing site to observe from. If you're not fortunate, like most of us, we have to go outside the city in order to see a comet like this. And it's just not going to be bright enough to see with the naked eye. In more northern climes, say in Washington State or Minnesota, Maine, and parts of Canada, you probably can see it naked eye. But here in the southern part of the US, you are going to need the binoculars to find it. That being said, once you do find it, it is a pretty spectacular sight. Now, Comet NEOWISE did hold itself together when it made its perihelion pass. Perihelion is a term in astronomy, and it refers to when an object gets close to the sun. And so it made its perihelion pass on July 3rd. And we were waiting with bated breath to see what was going to happen. It was going to hold itself together, it was going to brighten up, or was it just going to fizzle? Well, as it turned out, NEOWISE made its pass around the sun, it held itself together, and it began to brighten. And amateur astronomers all across the northern hemisphere began to get up early in the morning to get out and see this comet. And there for a few weeks, you had to get up early in the morning, right before sunrise, in order to see it in the northeastern part of the sky. But now the comet has moved along in its orbit to such a point where it is now appearing in our evening skies in the northwest. Okay, so I mentioned it was discovered on March 27th. Let's talk a bit about the size of the nucleus of the comet. Most comets are about, I don't know, 5 to 10 miles in diameter. NASA has been able to measure the diameter of this comet, NEOWISE, and it turns out it's about 3 miles in diameter. So it's a moderate sized comet. And it is starting I guess I should say, as it was entering into the solar system, approaching the sun, it began to vaporize ices from its surface. Now, it's covered in ice, water ice, methane ice, ammonia, carbon dioxide, carbon monoxide, things like that. And it's also, like any comet, it's a dirty snowball. It's got all these ices, but it's also got a mixture of dirt, rocks, carbon materials that coat the surface. And actually, you might think that comets are bright, like a bright white snowball, but they're not. They are actually very dark because they are covered in this carbon soot. And it makes them very difficult to spot. But once they get closer into the solar system and the ices begin to heat up, they don't melt because it's in the vacuum, cold vacuum of space. The ices undergo a process known as sublimation. So they go from a solid state directly to a gaseous state. And these ices begin to spew off the comet and forms an atmosphere, a halo called the coma around the nucleus of the comet. And this can swell out to thousands of miles across. Coma means hair, by the way. And in ancient times, the Romans, for example, referred to comets that appeared in the sky as hairy stars or comas, coma stars. So the nucleus begins to shed all of this ice and gas from it, and the coma forms around the nucleus. And then a lot of that stuff gets blown back behind it, forms a dust trail. And that's what we're seeing here, following along in the wake, not necessarily in the wake of the comet. This stuff gets buffeted by sunlight. Sunlight does exert a pressure, and it forces that dust out behind the comet. We also have what's known as an ion tail, and you can just barely see it coming off the dust tail right underneath it there. An ion tail is ionized gas, hydrogen, carbon monoxide, carbon dioxide, things like that. It gets ionized. Electrons get knocked off the atoms and off the molecules. And when these electrons get knocked off, they eventually come back together and go back into their normal orbital state around the atom. And when they do, they emit a glow. And that glow is what we're seeing there in the ion tail. Now, where do comets come from? Well, we have to go back in time, 4.5 billion years, 4.6 billion years or so ago, to the formation of the solar system itself. And at that time, there was a huge, giant cloud of gas and dust that began to collapse in upon itself. And as the gases, dust began to collapse in towards the center of the cloud, it got really dense there, really hot, and allowed for nuclear fusion to kick in, and we had a sun. But as the cloud collapsed, the cloud began to spin, and it flattened out into a disk. And out of that disk condensed the planets, asteroids, and comets. And the comets that formed, a lot of them got kicked out by gravitational pushes and tugs by the planet Jupiter and the other large outer planets, and scattered them out into a huge cloud that surrounds the solar system in a cloud known as the Oort cloud. And some of them got scattered out beyond the orbit of Neptune in a region we call the Kuiper Belt. And still others got kicked out a little further and just beyond the Kuiper Belt into an area known as the scattered disk. So these are the main reservoirs for comets in our solar system. Comets can come from any one of these areas, these reservoirs. We think that Comet NEOWISE has come from the Oort cloud. And Oort cloud comets are what are known as long period comets. These are comets that come into the inner solar system, and it takes over 200 years for them to make an orbital pass around the sun. NEOWISE, it takes it now 6,600 or 6,800 years to complete one orbit around the sun. So I suggest you get out now and look at the comet, because most of us will be in the old folks home by the time this thing comes around once again. The short period comets, they usually come from the Kuiper Belt or the scattered disk. And there are comets like Halley's Comet, coming through about every 75 years or so. Or at least in the case of Halley's Comet. But most short period comets are somewhere under 200 years in their orbital periods around the sun. I'm seeing a little bit of a greenish glow there. I'm not sure if this is due to ionized cyanogens. Yes, there are other compounds in comets like cyanide, cyanogen, and it's composed of a form of carbon that when it gets ionized, it produces a greenish glow. The dust tail, it's usually, in comets, we usually see that as a kind of a yellowish, brownish glow to it. It's actually reflected sunlight off the dust granules in the tail. Okay, so now Comet NEOWISE is headed away from the sun, and it is going to come closest to Earth on July 23rd. And on July 23rd, it will be about 64 million miles away. From there, it's going to start heading further on out into the solar system and back out again towards the Oort cloud. And as I said, it won't come back around for another 6,800 years or so. Right now, it's in the constellation of Lynx, which is below the constellation of Ursa Major, the Big Bear, in which resides the Big Dipper. Over the next few days, it will leave Lynx. It will enter into the edges of Ursa Major, the Big Bear. And finally, it will come out in a constellation known as Comet Berenices. So we've got a good window of opportunity to see this comet over the next 2 weeks. However, we also have the moon coming back into our sky, and that's going to be problematic because as the moon waxes from new moon to full moon and gets progressively brighter, that bright glare from the moon is going to compete with the faint glow of this comet. And we want dark skies, as dark a sky as possible to see it. So I urge you to take advantage of the opportunity that we now have with the moon not being in our evening sky right now, and getting out and seeing this comet while you can. Tonight is an excellent night. And if you've got a pair of binoculars, get outside right now. Take a look. I'm going to head outside here in just a minute. I'll leave you to view the comet. And I'm going to go take a look at the comet myself with my binoculars that I brought up with me to the observatory tonight. So I'm going to head out. I'll be right back in just a few minutes. All right, I'm back again and took a look at the comet. It is a lovely sight. I urge you to get outside and take a look if you can. We were talking earlier about the tail, the dust tail of comets. And as the comet passes through the inner parts of the solar system, it heats up, as I said, and rather than the ice is melting, they undergo a process called sublimation, where the gases go directly, or the ices go directly from being a solid and go directly into a gaseous state. As this happens, parts of the comet will fracture. Vents will open up, cracks, holes will open up in the surface of the comet and vent a lot of this gas out into space. And as it does so, it carries with it ice particles and dust particles along with it. And that forms the dust tail. And the dust tail can stretch for millions of miles across the solar system. Now, here's the deal. When the Earth intersects one of these dust tails, we get a meteor shower. So when you are outside and you're looking at, say, the Perseid meteor shower, which is coming up next month, what you are seeing burning up in our atmosphere are particles left over from the passage of a comet. In the case of the Perseid meteor shower, I think it's a Comet Tempel-Tuttle. And as the Earth plows through this debris field left behind from a comet, those particles, no bigger than a grain of sand, slam into our atmosphere at tremendous speeds. And out in the vacuum of space, they had nothing to slow them down. They're going thousands, hundreds of thousands of miles an hour. And when they hit our atmosphere, it's like they've hit a brick wall. They slam into the atmosphere with great force, and they compress a column of air out ahead of them. And that compressed, shocked column of gas heats up to over thousands of degrees Fahrenheit and will actually glow. So that streak of light that you see produced by a meteor is caused by the compression of the atmospheric gases out ahead of this tiny little object entering into our atmosphere. And of course, as the column of air heats up, so too does that particle, and it vaporizes in the atmosphere. Okay, if you have any questions and you want to ask, feel free to do so. I will try and get to where I can actually see those comments. And we have a weird lag time going in from the Zoom feed to our live feed of the comet on YouTube. So kind of bear with us with that. Pardon me if I don't get the name right. Evan Iacano, you're asking where is it? If you are in the northern hemisphere, then the comet appears in the north. And Quick Shots AB, you're asking where is it in the UK? Well, it's going to be in your northwestern part of the sky too, but you're going to be a bit luckier than those of us here in Little Rock, Arkansas, in the southern United States. It's going to be a bit higher in your sky, but it's still right below the Big Dipper. So if you've got a good dark sky, get outside and see if you can find it. Use binoculars. And Armada, you're from Corsica, and you say you can't see it because you have mountains. Go to the top of the mountain if you can, and you should have a good clear view towards the northwest, hopefully, and see if you can see it that way. So yeah, let us know where you are viewing this from, and post any questions that you have. We are going to try and keep our telescope on the comet for as long as we can. We are kind of hindered by the fact that we have trees surrounding the property of our observatory here on Y Mountain. And we are probably going to lose the comet before too long as it goes behind those trees. But we're going to try and stick with it for as long as we can. Layla, you say that you have a cloud there in New Brunswick. Oh, I hate that. It happens here too. And the other night, I'd gone out to do some observing, and I had the same problem. Fortunately, though, the cloud that I had did eventually move. But here in the deep south of the United States, we're having to contend with a lot of atmospheric haze. We have very high humidity here, something you probably don't have to contend with there in New Brunswick. But here, it's a problem. And it was kind of obscuring my view of the comet. Now, comets throughout history, you know, they've always been portents of people to people. In ancient times, when people looked up at the sky, they didn't understand. They didn't even understand really what the Earth was. They didn't have a concept of what a planet was. They didn't have a concept of what space was. They didn't have a concept of what comets are. All they knew was all of a sudden these objects would suddenly appear in their sky. And since they usually associated the sky as being the realm of the gods, they usually interpreted these things as, well, it must be some sort of sign or signal from the gods trying to tell us something. And so throughout time, comets have been messengers of doom in some cases. And I'll give you a good example. If you recall your history, and William the Conqueror invading Great Britain in 1066. William the Conqueror came from Normandy, and when he saw a comet appear in the sky, we think it was Halley's Comet. He saw this comet, and to him, that was a fortuitous sign. He took that as a sign that he was going to be able to conquer the Anglo-Saxons in Great Britain. So he convinces everyone, hey, let's get our army together, head to Anglo-Britain and take it over. And he did. Now, King Harold, on the other hand, his advisors saw the comet as a portent of doom. It was a messenger of the death of the king. And as it turns out, both William and Harold's advisors were right, because William did succeed in conquering Britain, and Harold, at the Battle of Hastings in 1066, did take an arrow to the eye and died in battle. So yeah, there's that. But we now know, of course, that comets have nothing to do with prophecy of any sort. They are just visitors from the outer edges of our solar system, passing through and giving us a chance to get a good look at them. I should mention that comets, as being relics from the formation of the solar system, carry with them secrets or information that we can tease apart to learn about the formation of the solar system. We have sent probes. NASA has sent probes. The European Space Agency has sent probes. The Russian Space Agency has sent probes to interact with comets, orbit them, collect samples from them. And we have found that comets contain very complex molecules, including amino acids, the basic building blocks of proteins. And it is indeed possible that comets may have seeded the early Earth with the ingredients for life. We don't know this for sure, but it is certainly a possibility. We also believe that comets may have brought water to the early Earth. As the early Earth was forming, it's very hot. We don't think water would have stayed on the surface for very long, although there probably was outgassing from the interior of the early Earth. Water vapor probably formed and probably did condense to form water, but because the Earth was so hot, a lot of that stuff just would have vaporized. And it really doesn't account for the amount of water that we have on the Earth today. So we think that it's possible that asteroids and comets, and yes, asteroids do carry some amount of water in them, may have seeded the early Earth with water, brought water to the Earth. And that is entirely possible. Let's see. Jose, pardon me if I get the name wrong, Iraguayas, is it in the northwestern sky? Yes. And I don't know where you're viewing from, but if you are in the northern hemisphere, then yes, you will be able to see it in the northwestern part of the sky under the Big Dipper. And as I've advised earlier, use binoculars in order to find it. From our location here in Arkansas, it's about, when it first started out as becoming visible around 9:15, it was about 10, 15 degrees above the horizon. And Big Moon ASMR, yes, where is it at? It is in the constellation of the Big Dipper, right below it. Just take a pair of binoculars, find the bowl of the Dipper, and start scanning downwards towards your horizon. And you're going to find it closer to the horizon. So we're coming up on 10 o'clock here, and I think we're probably going to lose the comet behind the trees here shortly. So get your questions in while you can, and I'll try and answer them. And before we do cut out here in just a moment, I want to let you know that there is another great astronomical sight to see tomorrow morning. On the morning of the 19th, get up before sunrise, head outside, look towards the east first, and there you will see the planet Venus shining very brightly in the east. Just a little bit to the left of Venus and down below, very close to the edge of the horizon, and use binoculars. Once again, you will be able to see the planet Mercury. But it gets better. You also have the planet Mars there as you face south. And then towards the southwest, you'll see the planets Saturn and Jupiter. So you got 5 naked eye planets that you can see tomorrow morning. Let's see, we have a question from Stream Overlay Pro. You say, hello, if I'm in New York, can I be able to see it now? And probably not at this point. You're on a time zone, where it's probably already gone below the horizon for you. But get out tomorrow night, and just right after nightfall, get outside the city, get to as dark a sky as you can possibly find. See if you can locate the Big Dipper, and then see if you can find the comet below the Big Dipper, close towards the horizon. Once again, I have to emphasize the use of binoculars in order to locate it. If you do own a small telescope and you have not gone out to look at the planets Jupiter and Saturn, if you're outside right now and you're looking at the comet, turn around and face back towards the southeast, and you will see Jupiter glowing very brightly in the night sky. And then just a little bit to the lower left of Jupiter, you will see the planet Saturn. With binoculars, what can you see? Well, with Jupiter, you can see, you won't be able to see any details. You won't be able to see the bands on the planet, but you will be able to see the 4 largest moons of Jupiter orbiting around it. Io, Europa, Ganymede, and Callisto, depending on where they are in their orbit. But usually they're strung out like very bright little pinpoints of stars out around the equatorial sides of the planet Jupiter. With Saturn, you won't be able to see the rings with binoculars, but you will be able to see that it looks kind of like a bulgy star. It looks like a star with a bulgy midsection to it. But if you have access to a telescope, I urge you to look at both of these planets. They are extraordinary objects to see in a small telescope, especially Saturn. It's such a surreal sight. I've had people come up to my telescope at star parties and they take a look and they go, that's not real. I've even had people ask me to take my eyepiece out of the telescope and let them look at the inside of the eyepiece to make sure that I hadn't painted the image onto the eyepiece. It is that surreal looking. If you don't own a telescope, check with your local library. A lot of libraries nowadays are loaning out telescopes. We have started a program like that here in the Central Arkansas area. CAS, the Central Arkansas Astronomical Society, obtained funding through the Arkansas Space Grant Consortium, and we bought libraries, various libraries across the state actually, small Orion Star Blast telescopes. They have an aperture of about 5 inches, 4 or 5 inches. They are good quality telescopes, and we have made those telescopes available to the public. And a lot of libraries are doing this around the nation. So check with your local library and see if they've got a program like that going. If they don't, contact your local library, contact your local astronomy club and suggest that they initiate a program like that. Okay, I'm going to step outside just for a quick second and I will be right back. Okay, I am back. And we are starting to lose the comet behind the tree line. So we're probably going to end our session here. I hope you've enjoyed the program. We can hopefully do something like this again now that we've got the hang of the technology here. And I wish you all a good night and a very happy weekend. So good night from the Central Arkansas Astronomical Society. We hope to see you again soon.